What is up, everybody? Mr. Hissner here, and today we are going to be looking at what are called conditional statements. Now, once we learn this, we will spend most of the you will spend the rest of you should spend the rest of your math career thinking in terms of conditional statements. You should be able to apply this to most of your life. I mean, truly, conditional statements are perhaps the most powerful statements in logic. Um, these are these statements are the basis for all reasoning, all logical thought boils down to conditional statements. And so, for me, these are extremely powerful, and there's also other things that go along with these conditional statements, which are just as powerful as well. So this idea of this conditional statement and its three, what's that word? Accompanying statements as well are very powerful, and there's something that we will use and you will use. Mathematics uses, really this is the basis of all logical thought. That is kind of the basement of mathematics. All the thought that we do in math kind of rests on this idea that things are conditional, So let's jump into it. Okay, conditional statements. So you are going to be taking notes. I know. Notes. So conditional statements. These are what we call if-then statements. So we write these in what is called if. This is actually lowercase I. If-then. I'm having a tough time right now spelling. If-then statements. These are if-then form, and what that looks like, it's P, and then this arrow. And then Q, and this is read as if P then Q. This is read as if P then Q, or a better way to think of this is actually that P implies Q. This is if P then Q is a nice way to think of it, but kind of a nice, dare I say, logical way to think of this is that the statement in P is implying that Q is true as well. So the hypothesis is the phrase following the word if. So the hypothesis is the statement following if, and the conclusion is the statement following the word then. So we have P in this. If this was if P then Q, P would be our hypothesis, and then Q would be our conclusion. So let us look at just some examples of this and just kind of pick this apart a little bit. So if you live in Nashville, then you live in Tennessee. Okay? So what is following the if? This is our statement P. And what is following the then? This is our statement Q. And so our hypothesis is you live in Nashville. Right? You live in Nashville. And then our conclusion is you live in Tennessee. That's two N's. Tennessee. So that's how we handle these. Now let's look at one that's going to be more related to us. So if the sum of the measures of two angles is 90 degrees, then they are complementary angles. So our hypothesis is the sum of the measures is 90, and then they are complementary. They are complementary. So I think you get the idea. What we're doing is we are taking the statement. This is the statement after the if. That's our P. That's our hypothesis. And then our conclusion is the statement after the then. And so what we really want to do is kind of do the opposite of this. We want to create these statements, right? So we want to identify a hypothesis and a conclusion. So look at this first example. It says, an obtuse angle has a measure greater than 90. Greater than 90, right? So there's more than one way to do this, of course. So what I'm going to do is, right, I'm going to say if, give myself some space, then. So what I'm going to do is I'm going to take the first part and put that as my hypothesis. This is my condition. If an angle is obtuse, then the measure of the angle is greater than, the measure of the angle is greater than 90 degrees. So that's how I'm constructing this. I'm taking these two parts and putting a condition on them. So let's see. Let's look at this next one. It says all numbers are divisible by 4. All numbers that are divisible by 4 are also divisible by 2. All numbers that are divisible by 4 is, so what I'm going to do is I'm going to make an if. If a number is divisible by 4, so if, let's pick 1. If a number is divisible by 4, then it's also divisible by 2. Then it's also by 2. What do you think? So the idea here is that we are taking these pieces and putting them into an if-then form. States on the East Coast border the Atlantic Ocean. If a state is on the East Coast, then that state borders the Atlantic Ocean. Ta-da! Is that true? That means that Pennsylvania is not an East Coast state. We're in the heartland. So that's what we're going to be doing today. Make sure that you are taking some notes, especially on conditional statements. And thanks for watching.